The second production project is this wheel design. And it's a 5-spoke wheel, so we're looking at a repeat of 5 72-degree segments. But that segment has got a centre line of symmetry as well. So we can get away with one 36-degree wedge, and then just mirror it and duplicate it around the whole wheel. So that's what we're aiming for. So I'll just turn off that finished example. And I've provided you with some curves to start with, or of course you can create your own. But before I start to build, the most important thing to do is check that I've got the right construction tolerances set. And if you remember, I took a fairly accurate preset here and copied it to create my own tolerances. And I did that so that I could tighten up the trim tolerance. But it also means that I've got freedom to modify these rational flags, which is important when I'm revolving surfaces. And it will depend on the accuracy that I need. So for example, for the tyre surface, I'm only going to use that for visual purposes, so it doesn't need to be accurate. So for that, I'll leave the rational flags off. And then I can use the Revolve tool, and I'll just start to revolve it and see what I get. And that's going around the wrong axis, so that'll need to be the y-axis. And if I do it global rather than local, then it gets the right shape. And global lets me have more than one curve, so I can just pick that rear curve as well. And if I turn on the CVs, you may recognise that I get the slightly ungainly CV layout of a non-periodic circle, which is economical but not very accurate. But that's fine for the tyre because we're not going to be manufacturing from my data. But now if I switch to the steel rim, this does need to be accurate for manufacture because I'm going to be building my spokes onto it. So I'll go back into the construction options and I'll set the rational flag on for new surfaces. So now if I want to do a full 360-degree revolve, and I've got chain select on, so it picked all the curves, then I get my steel rim, which should be accurate. And I can check that with a radius locator on any of the isoparms. And if I move that around, the value doesn't change. So it's consistent and accurate all the way around the rim. Alternatively, I might decide to do just a segment. So I'll query edit that and just go to 36 degrees. And this is still building at rational, so it's still completely accurate. But for partial revolves, I can also work with non-rational. So I'll delete that one and go and set my construction settings to non-rational. And then if I do the revolve again, and then check the radius, you can see that it's changing very slightly, not a lot, but enough to be a problem. So if I'm using non-rational, then it's the degree that's important. So if I increase this to a degree 6 and then check it again, now it's spot on and I'm confident that it's accurate. So I'm happy with those settings, so I'll continue with them, and now I'll go and create the front surfaces. And I'll turn off the rear curves as well. So now I'll do a revolve with the same settings, and chain select takes those 3 curves. But here there's a sharp edge, so I'll need to do another revolve for that one. Now if I'm building for production, then it makes sense to periodically stitch the surfaces to check for gaps. But here something strange has happened. And I'll just move that aside so we can see it better. So it's gone weird on this central surface. And the reason for that is that this surface has got a degenerate point. If you remember, one of our golden rules states that surfaces should always have 4 sides. But here I've only got 3 sides. And in fact there is a 4th side, but it's collapsed onto one point in the centre. That's the degenerate point. And that causes problems with stitching, data transfer and rendering. So I've got a few options to rebuild it in a different way. Because it's flat, then I can use the planar surface and just use the boundaries of the revolve. And if I turn on the CVs, you can see that it's actually a square surface that's been trimmed. So I can untrim that to show you. So there's no degenerate points on the planar. But I'll end up copying that around. So what I might do instead is get rid of both of those. And I'm now going to create an accurate perimeter by this time making sure it's accurate, and then revolving again at 360 degrees. So this surface has still got the degenerate point in the middle, so that's not going to fix the problem. But what I can do is just use the perimeter to create another planar. And then if I get rid of the revolve, then you can see again it's a trimmed surface. But there's no degenerate point. So let's see if that will now stitch. And I'm happy with that. So you can do the rear surfaces in the same way. And in the next section we'll build the spokes and work with construction planes to make sure everything is smooth across both the symmetry planes that we've got on the wheel.